Hi, I hope everybody's staying well. Today we are going to review Boyle's Law, and then we are going to start Charles's Law. Okay, let's review the kinetic molecular theory. The first part was that a gas consists of small particles, each of which has a mass. If we took the mass of a deflated basketball and an inflated basketball, the deflated would have a lower mass. The volume of the gas particles is assumed to be zero. They have essentially no volume compared to the space between them. Gas particles are in constant rapid random motion so that a gas will immediately fill its container. And the average kinetic energy, how fast they move, depends only on the temperature of the gas. High temperature means a high kinetic energy, which means it's moving faster. A low temperature, low kinetic energy, they're moving slower. And gas particles exert no force on one another. Okay, let's review our units again. Pressure, most common is millimeters of mercury. This is what our blood pressure is taken in. And atmospheric, other units pascals, or sometimes you will see kilopascals. And PSI, pounds per square inch. This is what you most commonly see on tire gauges. Temperatures. Temperature is Celsius and Fahrenheit. Celsius is what we usually use in science. However, with the gas laws, we want to always use the Kelvin. So that is Celsius plus 273. Volume is in milliliters or liters. For gas problems, as long as they're the same throughout the problem, everything's fine. What we consider our standard temperature and pressure. Standard temperature is 0 degrees Celsius or 273 Kelvin. Standard pressure is 1 atm or 760 millimeters per mercury, 14.7 psi or 101.3 kilopascals. Boyle's law, a fixed amount of an ideal gas kept at a fixed temperature. The pressure and volume are inversely proportional. Remember, that means as one goes up, the other goes down. There's the formula again. Pressure 1 times volume 1 equals pressure 2 times volume 2. So again, that is a review for Boyle's law. So let's talk about Charles's law. Charles's law states that the volume of a given mass of an ideal gas is proportional to its temperature as long as its pressure remains the same. So what this is saying is that as our temperature increases, our volume increases. As our volume increases, our temperature increases. Or as our temperature goes down, then our volume goes down. And the same is true as our volume goes down, it's going to decrease our temperature as well. Which is why if you take a can of compressed air and squirt out the gas, as that volume is decreasing, the can gets cold and the temperature gets, and the can gets cold as the temperature decreases. So the formula for Charles's law is V1 over T1 is equal to V2 over T2. Okay, so we know our formula, so now we need to be able to figure out how to solve for each of the variables. So for volume, if we are trying to solve for our initial volume, then we need volume by itself, so we need to multiply both sides times T1. These T1s cancel out, so we have V1 is equal to V2 times T1 over T2. 2. If we need to solve for our ending volume, we need to get our volume by itself. So we multiply both sides, in this case, by T2. Cancels out. So we have V2 is equal to T2 times V1 over T1. Or V2 is equal to T2 times volume 1 divided by the initial temperature. Okay, so solving for our temperatures is a little more tricky, but it's doable. So if we want to solve for T1, first thing we need to do is get it into the numerator. So we multiply both sides by T1. These cancel out. So now we have V1 is equal to V2 times T1 over T2. We are solving for T1. So we need to multiply both sides by the inverse of the V2 over T2. So T2, V2, and then on this side, T2, V2. So these cancel out. So we have T2, V1 over V2 is equal to T1. So another way to write this would be T1 is equal to T2 V1 over V2. Okay, so now we want to try and solve for T2. So the first thing we need to do is get T2 into the numerator. So we multiply both sides by T2. T2 cancels out. So now we have T2 V1 over T1 is equal to V2. So now we need to get rid of the V1 T1 by multiplying both sides by that inverse. So T1 V1 times T1 over V1. So the T1 V1 cancel out. So we have T2 is equal to V2 T1 over V1. Okay, now for a few practice problems. Okay, so practice problem 1. Oxygen gas is at a temperature of 40 degrees Celsius when it occupies a volume of 2.3 liters. To what temperature should it be raised to occupy a volume of 6.5 liters? So our initial temperature is 40 degrees Celsius. Remember, in the gas laws, everything needs to be Kelvin. So it should be 40 plus 273 is equal to 313. And our volume at 313 Kelvin is 2.3 liters. Our ending temperature is our unknown, so that's what we're looking for. And our ending volume is 6.5 liters. It's 6.5 liters. We are solving for T2, and so our Okay, so our formula is T2 is equal to V2 times T1 over V1. So we plug in our numbers. V1 was 2.3 liters. Our V2 was 6.5 liters. And our T1 was 313 Kelvin. Liters cancel out. So our T2 is going to be equal to 884.6 degrees Kelvin. So T2 is equal to 884.6 Kelvin. Okay, our practice problem number 2. It says that a hydrogen gas was cooled from 150 degrees Celsius. So that is our starting temperature, to 50 degrees Celsius. So that's our ending temperature. And its new volume is 75 liters. So T1, T2, V2. So it wants to know what was the original volume. So this is our unknown. T1, our initial temperature, was 150 degrees Celsius. We need to convert that to Kelvin, so 273 should equal 423 Kelvin. Our volume was 75 milliliters, and our ending temperature was 50 degrees Celsius, or 3 plus 273 is 323 Kelvin. Our formula should be V1 is equal to V2 times T1 over T2. So we plug in our numbers. V1 is equal to 75 mils times 423 Kelvin divided by 323 degrees Kelvin. Our K's cancel out. And so our ending number, when we plug this into a calculator, V1 is equal to 98.2 milliliters. Okay, and we have one more practice problem. Okay, last practice problem. A chlorine gas occupies a volume of 25 mils at 300 degrees Kelvin. So it's already in Kelvin. We do not have to convert. What volume, it wants to know V2, will it occupy at 600 Kelvin? So it starts out with 25 mils, and it told me 300 Kelvin, and it wants to know the volume, the second volume, and then it wants to know 600 Kelvin, 600 Kelvin. Okay, so our formula for this is V2 is equal to V1 times T2 over T1. Okay, so plug in our numbers. We have V2 is equal to 25 milliliters times T2, which was 600 degrees Kelvin, divided by our initial temperature, which was 300 degrees Kelvin. And so our answer should be 50 mils. And we plug that into a calculator, 50 milliliters. So our V2 is equal to 50 milliliters. Okay, I hope this helps with working through some of the Charles Law problems. And y'all stay safe, and I will talk to you soon.